Thanks for joining us on this episode of the Entrepreneurial Space podcast. Today, we are excited to introduce Shankar, co-founder of Antares Inc. and Eartheye Space Technologies. Shankar is based in Australia, but he operates around the globe. His extensive career includes leadership positions at big tech companies, including Hewlett-Packard and OpenText. More recently, he moved to Planet Labs. He founded two new space startups, one upstream and one downstream. And Antares is his latest company, which offers a product that helps companies to configure, deploy, and develop satellites. Welcome, Shankar.
Thank you, Jeremy. Thank you, Balaji.
So for starters, thanks so much for joining this interview. It's very exciting news about the company. Would you please tell us about your career and what brought you to the point of establishing your own new space company? And also, if you tell us a little bit about the vision for Antares and Eartheye Space Technologies.
So I'll start with my career. So I started my career in technology. So as an undergraduate in computer science and engineering, I moved on to work in technology companies. And so my longest stint in technology was with Hewlett-Packard, as you mentioned, Jeremy, and I spent nearly 13 years there doing various roles. I even did a relocation during that 13 years from Singapore to Australia. And so that was a very formative time in my career. And subsequently, I joined another software major called OpenText, a Canadian information management company. I wanted a software experience, and so that was very productive time at OpenText, nearly 3.5 years. And while at OpenText, I got a call to look at a company called Planet Labs, and which I'd never heard of before. And I'm through and through a tech guy, and I whilst I had interest in space, I never really paid attention to the space company. So I looked at Planet Lab. It seemed very interesting, and also given my background in analytics, and I realized there was a lot of value in what Planet was doing with respect to the downstream last mile value in delivering insights from the data that is being collected. So I jumped at the opportunity, and I joined Planet Labs, and that was my foray into space, new space. And since leaving Planet Labs, I had the fortune of, or the privilege, I should say, of working with a couple of other new space startups. So Planet Labs, while it's the kind of the poster boy that everybody knows for new space, there are also a couple of other equally well-regarded, well-known companies that kind of play in the new space, but in adjacent areas to Planet Labs or Planet. So one that was that I worked with in the early part of doing consulting was a company called Spire, which is also an Earth observation, but instead of taking pictures, it was doing more of RF sensing for various different scenarios, including maritime, airspace, weather, and so forth. And then the other company that I had the most privilege and I continue to consult is a company called Satlogic, and which is out of Argentina. And that was another great experience because they're kind of the best kept secret, and they're doing things very differently and very cost efficiently. So when I look at their model, they're all vertically integrated. That was a common thread between all three companies. They were all vertically integrated, but they gave me a great experience, and I could see the sort of the best practices and those that then could also be done differently and better. And then what happened was some of the founders, the founders at Antaris and I ended up in a Kubernetes startup. So I've been following Kubernetes for a while, and while at Planet we used Kubernetes in the early days, and so that was very exciting to be able to then work in the Kubernetes space in the last couple of years. So while working in Kubernetes, and that gave us an opportunity to look at the space particularly, I mean in general, and satellite in particular, to see is there a better way to design, configure, build, manage satellites, right? So because just like Elon had transformed the rocketry, the launch business through reusable rockets and so forth, the satellite to most extent, even in a vertically integrated companies that I worked at also or elsewhere, it is still done in a very traditional way. So there's a lot of reinvention that goes on in building a satellite for every mission, and it is still very inefficient, and there's a lot of friction. That was the number one issue. There's a lot of friction in the satellite in the satellite value chain. So that's when we realized there must be a better way to do it. So we came up with this idea of software-defined satellite, which is modular, microservices based. Some of these lessons coming from our Kubernetes experience, and how do we then orchestrate a satellite microservices architecture in a distributed, highly resilient, self-healing environment. That's why we came up with the software-defined satellite, which then meant, satellite is not just software. There's a lot of hardware that needs to work together. Then how do you then bring the hardware, i.e., how do I then abstract away the hardware so that it becomes plug and play? That was the birth. That was the big idea of Antaris. So if you were to then say, how do we make it easy to build satellite? Then we said we have to start that whole journey with not just saying software defined, everything needs to be open API based. So we said we'll have to build a platform which people can engage and build their satellites so they can conceive a mission and design, configure, build, launch, operate the satellite throughout the life cycle from a terrestrial cloud. So we want to make that experience of working on a satellite, just like you work on AWS or Azure or Google Cloud to do your IT project. The same idea, how do I now take a satellite as a project and actually design, build, launch, operate in a public cloud? That is the thinking, and therefore we designed this platform, this SaaS platform to deliver the life cycle service of a satellite, right from conceiving the mission to designing to all the way operating and decommissioning as a SaaS product. So we are going to be the first software as a service for satellite on a terrestrial cloud. So that's how we're trying to make this whole thing easy for mission owners to build a satellite. And in the process, we remove friction. So how we remove friction is the two-sided business model in Antares. So the one side is the SaaS, where you're engaging the platform to design, build your satellite. On the other side of the platform, we aggregate the suppliers. So it's a marketplace where we aggregate suppliers who are validated against the Antares platform. So if I'm a mission owner and putting a satellite together on the Antares platform, it's a low-code platform. Then on the canvas, as I build the satellite, I have my the partners or the suppliers of the ecosystem exposed through that low-code platform. So I can now plug and play with those qualified suppliers. So what we have done, therefore, is to remove that supply chain friction, right? And so you are very quickly able to do a modeling and simulation before you actually go and engage to buy the actual hardware and integrate, launch, and do the AIT, launch, integrate, and fly and manage. So that's in a nutshell how we are going about doing this.
Okay, so can I think I'm understanding this as a very interesting advanced concept. Like, first of all, like Balaji and I come from big tech background, okay. So I think we can definitely appreciate that it feels like in the in the new space industry and old space also by default, there's maybe a lot of legacy systems and a lot of the big tech trends and concepts such as cloud, software as a service, maybe even automation and application of AI and things like digital twins. These concepts that have had big impact on tech. You're kind of taking advantage of this gap right now. Is that right? This software technology gap in
absolutely. I'm spot on, right? So you threw in a few concepts there. So yes, so I mentioned software-defined satellite. So just like software-defined anything, right? So here we are talking about software-defined satellite. We are talking about SaaS, and we're talking about cloud delivery, right? Terrestrial cloud delivery. We're talking about microservices. we're talking about, more importantly, the last point you raised, Jeremy, we are talking about doing CI/CD pipeline to space. So right from terrestrial cloud, where you have now designed your satellite and built it and launched, you have a carbon copy or a digital twin instance in the terrestrial cloud, and now you are managing your asset in space through a CI/CD pipeline, right? So you do a lot of the modeling and simulation on the terrestrial cloud with the digital twin of that asset in space, right down to the component, right down to the reaction wheel, if I may. And then that's how we are also then enabling the CI/CD along with the digital twin of the spacecraft.
All right, very interesting. So yeah, so can I do a sort of thought experiment? Just to give you an example. So I'm a customer who's coming to you, and
yeah,
and I use your platform, which is a a browser application, correct?
Yeah.
Gateway. So so I could come to the platform, and I could come and I could propose to build a new satellite that is 500 kilograms, let's say, and I want to launch it to geostationary orbit around the Earth. I want to strap on a SAR sensor, synthetic aperture radar, and an optical camera, and I want to make continuous observations and transmit back data. And I want the data to be available to me, perhaps this is maybe a stretch, but not even as a batch process where I get routine weekly updates, but maybe in near real time, or and it's available to me on the cloud, pre-processed, pipeline is already made. Is this all within the scope of the services that software satellites as a service for Antares would include? Would it allow me to do all these things? Or
yeah, now brilliant. So yes, so the platform will allow you to do everything you said from a life cycle standpoint, absolutely, including operational management the way you described. The only caveat is currently we are focused on, because we are simplifying this, and therefore, when you try to simplify and make choices, you also need to then make sure that it's like Lego blocks, right? You build the Lego blocks or Lego bricks so that when you put together, you can create a final form. So therefore, because of that principle, we are limiting the design of the satellite. Not that because it's software, it's a piece of software, and you could technically argue that you can build a funny shaped satellite, because most of the satellites that go to geo are funny shapes. But we are more focused on enabling building of standardized satellites. So what I mean by that is CubeSat standards. So whether you're putting in a PicoSat or all the way to 56 use CubeSat, large CubeSat. So for example, we are qualifying the software we are building in July by actually launching satellite ourselves. Now, we are not in the business of building and launching satellites, but we need to qualify our own software. So we are building a 6U CubeSat farm satellite, bus satellite with, and we are going to fly 4 to 5 different payloads. And these 4 to 5 different payloads are completely different. They're all doing different things, everything from laser optical to some sensing and everything in between. Right.
What about communications? Sorry, Shankar.
No.
Communications also?
Yeah, the laser optical is a communication payload.
Oh, okay, sorry. Okay.
So laser optical is a communication payload. There is an IoT payload. There is some imaging payload. There's a 3D printed housing payload. And so some very interesting payloads that are going to be carried on this 6U satellite. So where I'm going with this is, so we're going to sort of drink our own champagne, so to speak, by being able to put the 6U through this sort of a Lego block approach. So to your question, Jeremy, so the scope of the platform is at least validated to build satellites, in our view, up to 300 kilos. So a 300 kilo satellite is basically your small sat category. So that's everything up to micro and mini. And so that's where the kind of the range of offering going to be. The moment you go beyond the 300 kilo class satellite, you're getting into other areas and other sort of complications, which we want to make sure we get the basic steps right in enabling. Because when people are talking about LEO constellations and a small sat constellation, it's basically within that 300 kilogram class, right? So whether it's a CubeSat standard, whether it's ESPA standard. So we will very much also enable those who want to fly ESPA bus, not just a CubeSat bus. So all of that is still possible within that plug and play model.
So you will not touch the hardware piece, but you are going to demonstrate the technology by launching your own satellite, as you said, CubeSat, to make sure the software and everything is working out.
Correct. So we because our model is to completely abstract away the hardware. So the mission owner is putting a satellite together, can plug and play any hardware out there, not constrained by cost, time, supply chain issues, because it's open API based platform with interfaces provided to connect any hardware out there, whether it's from an existing provider or newcomers into the space sector.
Got it. Thank you.
And let me move on to the next one. In the current COVID era, many workplaces have moved to remote. So is there any reason to choose the business location of the company in San Francisco or Singapore to any other places?
Right. That's a very good question. So we always wanted to have this as a Valley company, because a lot of the innovation, end of the day, it's a software company, and that's how we got also recognized as it's a SaaS company, just happens to be in the space sector. So as a software company with that level of innovation, just like what Planet has done, is to bring that agile aerospace, and it's San Francisco based. For us too, it was very logical that we would be a Valley company. And also the fact that 2 of the 3 co-founders are also based in California, so it just makes sense. And I am based here in Australia. And while we have a headquarters in the US, we have subsidiaries in Australia, Singapore, and India at the moment.
Okay, cool. So most of your staff would be located in US, or kind of very much dispersed around the world?
Yeah, the pandemic, to your earlier question, has taught us that you don't really need to be in one place to be able to work together. If you were starting this company in 2018, I think the first question that we would have been grappling with is, would it work? Because 2 founders there, 1 founder here, and the team is dispersed in India and so forth. But pandemic has taught us that we could actually work productively and get things done. So I think that it's been a good experience forced on us. So with that said, most of the team is actually in India, because we are a software company, a product company. So a lot of the software development, whether it's embedded systems or whether it's a cloud systems, it's all happening in India.
Okay, cool. So moving on to the next one. So in case of funding, what are your sources of funding, whether it's kind of venture capital or probably government or maybe corporate? And like in one of the LinkedIn post, I saw that you got some grant from the universities too. So can you briefly discuss about that?
Right, great question. So primarily our funding source, at least the dilutive funding source, is VCs. So we've been fortunate to get VCs who focus on, angel investors who look at pre-seed, seed kind of companies. So we've been able to have some of those folks support us, but we've also have our backers who typically do Series A and A plus or B. So they have even come in at this early stage. So that has also been good. So it's an indication of their expected longevity with us, hopefully. So we are primarily venture funded as far as our current round is concerned. And in addition to that, one of the reasons for setting up these subsidiaries in these countries I mentioned is also to be able to then work with the local ecosystem. University is a very important ecosystem for us, because one part of the Antares proposition I haven't gotten to talk about yet is open source. So the way we are going to build the community is by open sourcing significant portion of the software. Now, because it's all well and good for us to build this platform and deliver as SaaS, but if you don't have that critical mass of that ecosystem, whether you are a component supplier or subsystem provider or a payload provider or or a ground station service provider, integrator. There's a whole gamut of ecosystem, right? Whether all of these folks will only participate in a proposition like Antares if we were to if we can remove the friction for them, right? And the one way to remove the friction for them, as well as at the same time give a level of confidence to the mission owners, the customers who are going to build a satellite, is that there is an open source alternative, right? So think of us as a Linux and Red Hat Linux. So the early days, the way I used to tell the story, there's a Linux distribution and there's a package Red Hat commercial distribution. So our SaaS product is the commercial Antares distribution, but there will always be an open source Antares community edition, right? So that is the one that everybody participates in. That's why university ecosystem is very important for us, and therefore setting shop in some of these countries have meant we work very closely, the likes of NTU in Singapore, Nanyang Technology University with the Satellite Research Center there. We work with them very closely, and to your point, that is where we apply for grants with the governments such as Singapore. So we put collaborative proposals to work with these universities in getting grants. Now, while grants are good, they are non-dilutive. The reason for going down that path is not just getting some money, but more importantly, getting the university ecosystem work together with us and actually produce capabilities that eventually gets integrated into the Antares platform, because open source will grow the platform beyond what we imagine to be.
Okay, nice. So in case of the capital, I mean, was it difficult to raise the capital? How was it? How was the response from the universities or maybe your other investors?
Yeah, no, that's a good question. So fortunately, I think there's a couple of things that we have learned through this capital raising that matters to a lot of the angel and seed round investors, because they haven't seen the product, and so really what they are investing is in the team, right?
Yeah, that's true.
So they're looking at who's the team. First of all, there must be a good idea. I would say half and half in terms of the people who invested in us. Half and half looked at TAM. That means half of the investors looked at the total addressable market we were going after. Other half didn't bother, right? Okay. But what they all universally bothered was, what is the idea? Is it a hard problem these guys are solving? And what is the team behind it? And that's how they kind of, it's a kind of a leap of faith. So I think you need both. It's just, if you had a good idea and not so known team, I think our planet heritage was hugely positive. Plus the fact that, I've seen the other news space, I've done the rounds in other news spaces also added to that. But I think our combination of us coming from infotech, so that's the other good thing. If you look at, because we are creating a software product, it's not necessarily a space product, satellite. It happens to be for satellite, but think about it this way. This platform tomorrow can be used to build any other mobile asset, right? It can be a drone. I can actually build a drone using this platform, or some underwater vehicle, right? So you could think of, because end of the day, this is a software platform with APIs to integrate your hardware, right? So which means the way people look at our team and said, oh, these guys have actually been in infotech for the longest. So Tom had been in Red Hat for a long time, before Rackable Systems, again, which he took it for listing, and before he ended up in Planet Labs, right? So he's done his rounds in technology companies. Karthik has been in Microsoft and Nokia, right? And I have been in HP, OpenText, and so forth. So we have done that rounds in the tech companies before we came to space. So I think that was a good sort of
transition point.
Also from a VC point of view, they could see that these guys had a good blend of tech and infotech and space tech to do what they are trying to achieve, right? So I think that was also an important part there.
That's true. Yeah, that's an interesting mix of experience, actually.
Right. If I want to make my own, even CubeSat right now, then but I want to do it vertically integrated. I'm going to have to make my ground station, I have to have a facility for actually constructing it and then testing it, laboratories for testing it, make sure the sensors work properly, and then I have to piggyback on a launch vehicle. There's many, I've got to do pre-processing pipeline. There's many challenges and associated with that. And it sounds like you're removing so many of those obstacles. And because you can do it at scale, it would be much cheaper for, someone who's doing a startup who wants to put a satellite into space to go through, a service such as yours, I imagine. With that in mind, I feel like reading recent news and keeping up on new space, you have a lot of competitors in the space too. I realize. There's some examples of that are ISIS Space, Spire, as you mentioned earlier, who you collaborated with. Also, Loft Orbital. Loft Orbital recently got $150 million to create a constellation for Earth Daily. And they have these ambitious plans of, granted, they're doing hardware also. I understand you're not dealing with the hardware aspect, but I think that my understanding is many of these are planning to do the full gamut, right? They want to do software as a service in addition to actually constructing the hardware, and you just kind of put it in an order, and supposedly anyway, everything magically works and you have your data on the cloud. This seems to be the model of many of the competitors. So that just takes me to my question of like, what, with all these competitors and an obviously, extremely valuable and fundamental product, why is now the right timing for it, and what differentiates your service for Antares?
That's a great question. So I think I need to take a step back to kind of talk about why. I think you very nicely premised the earlier point, Jeremy, about as a startup, I don't have to do all the heavy lifting, and Antares as a platform will make it easy. Absolutely. The reason is also, the key point there is, today, if you are building your satellite or a constellation, and as a startup, it is harder than, it's hard for everybody. For startups, even more harder, particularly because our research shows 60 to 70% of your mission is actually spent on building the satellite. So think about it. So if I'm a VC and I'm investing in a startup that is looking to solve a particular use case, that could be putting up a sensor payload in space to collect data, to do some analysis, or to solve some problem, right? Now, if a VC is giving $100 to the startup to actually solve the problem on Earth, or potentially also moving forward, there are problems in outer space that you are looking to solve as well. But instead of solving that problem with most of the $100, you're actually only now able to solve that problem with $30. The $70 is actually wasted on the means to that end, which is to build a satellite to take your payload, to get the data from the payload, to solve the problem you set out to solve, and therefore you went and pitched to the VC to get the money. And that's a fundamental problem. So we want to make sure, it's almost like the analogy I give. When I donate $10, if I donate to a charity, I want most of the $10 to go to the recipient. I don't want most of the money going for administrative purposes, right? That's how I decide who I give my charity dollar to. Same concept. So we want to enable people, startups included, to do the satellite bit at the lowest cost, no more than $2, $3, right? At the tops, $3, $4, not $7, right? So that is a massive capital preservation. So that's capital saved, and also make it, as I said, make it faster, better, cheaper. It sounds cliche, but that's what it means, because now we are, through this platform, you have choices, so you are not beholden to some supply chain and some vendor lock-in challenges. So you can do it faster, better, cheaper, right? And through that process. So having said that, in terms of the Antares value there, I want to then address some of the some comparisons you made. So you have these vertically integrated companies, such as the ones I have worked with, consulted with, the Spires and the SatLogics, not Planet Labs. Planet Labs is not in the business of space as a service. Planet Labs is in the business of delivering Earth observation data and analysis. But Spire and SatLogic as an example, and also ISI lately on the SAR side of things, are now talking about delivering their capability. And this is one of the work I did with these companies. So with my work with Spire and SatLogic was essentially on the space as a service. Take your existing capability, which you have built to do your data business, sweat that capability or sweat that asset in terms of what you have built and the capability and the supply chain you already got going to create assets or satellites and constellations for others, right? So hence the space as a service or satellites as a service. I think there is a space for, pun intended, there is a space for these companies, these vertically integrated companies, to continue to provide that service. Absolutely. So they could have two revenue streams, the data revenue stream and space or satellite as a service revenue streams. Absolutely. But that is also very similar to the model of loft orbital. Think about it that way, because what you're doing with the Spires and SatLogics and loft orbitals, you don't care about the spacecraft, you only care about your payload. So you take your payload to any of them, whether it's loft, whether it's Spire or SatLogic, and they integrate and fly it in their spacecraft, and then you go and do what you want to do with the data. I think there is a business model and a market for that. We are playing in the other side of the spectrum, where if you want to be the mission as a mission owner, you want to own your mission together with the satellite. That means you want to have control on your satellite and how you're designing it, whether it's a single satellite or a constellation. Then we are providing a platform for you to have the choices and the flexibility and the lower cost and the faster time to build your satellite or a constellation, fly with your own payloads. Now, there are interesting business models that can emerge from this, because you can have a single customer now building a satellite with multiple missions, multiple payloads, right? Or you could have multiple customers doing a ride share on a single satellite, multiple mission owners riding on a single satellite, just like our own tech demonstrator, 6U satellite flying 4 to 5 different payloads. Now, that could be a new emerging business model for somebody to say in our ecosystem, hey, I want to deliver an Uber share experience. So I build a satellite. So I am Jeremy and Balaji company. All you do is on our platform, you advertise saying, I am going to be flying a 3U satellite tomorrow. I'm going to be flying a 6U satellite day after. I'm going to be flying a 12U next month. Anybody interested in a ride? And I'm going to this orbit or that orbit. And you basically, just like Uber Share collects passengers, you could collect payloads and you could take them. So now it's a different business model, right? You are now riding your own business model through this platform. So I think there is a place for both. There's a place for the loft and the Spires and the SatLogic, which, by the way, they are kind of in the same business model, because it's almost like outsourced business model. I take my payload, it's like a BYO payload to them, right? They provide the bus and they will launch the satellite. Here, we are providing a platform for you to be in control to do the whole 9 yards, so to speak. Everything from conceiving the mission to owning the mission, the constellation that goes with it, to decommissioning. So then the question is, who are the customers for these two different business models, right? So there are customers for both. So who's likely to be the customers for Antares would be the next, probably the follow-up question. So if I'm preempting that, it is space agencies, it's governments. So today we are engaged with countries in, whether it's in Southeast Asia, in Africa, there are close to 100 space agencies, but how many space agencies actually have space assets, right? So today those space agencies rely on the either large spacefaring nations. So Antares is a model for these countries to have their own space capability, and this is also the open source angle coming in here. So we are really reducing the barrier to entry for space agencies, startups, companies. You can expect tomorrow companies like Rakuten to wanting to fly their own satellite or a constellation, operate their own constellation to support their existing businesses. Don't necessarily have to go and solve a new business, create a new business, just as an additional source of data to support the existing business. Might just tomorrow decide to say, I want to have my own constellation in space. And today, without an Antares-like platform, there's tons of friction. With Antares-like platform, I just stay within Antares and I go through my entire ownership of the constellation and solve my problem by doing whatever I want to do in space.
I was just curious. I mean, you mentioned about some of the, I mean, how you can manage a space assets. So are you thinking of owning some ground stations, or I mean, probably a cloud-based service in the future, or how does it
Right.
work?
No, great. So we would integrate with all the ecosystem partners, right? So if you take a mission owner point of view, the design principle is we are removing friction at every point in the satellite value chain. So one of the value chain points is the ground station integration or ground segment connection. So again, we remove that friction by having ground station providers such as AWS ground station business, such as Azure Orbital. We would look to partner with likes of Infostellar in Japan as an example, KSATs of the world, including individual country ground stations. Because essentially, so long as you have an API to work with, we will integrate. And what that means is then for the mission owner, they now have a antenna cloud, if I can call it. They have an antenna cloud that they can access from the Antares platform as they operate their mission in space. They can now uplink and downlink, looking at the options they have, because no longer now you are limited by, hey, I need to work with this provider, this ground station provider, and therefore if I miss that overpass and if I couldn't uplink or downlink, I have to wait for the next one, right? So here, because I turn the antennas on Earth into a cloud by aggregating another, so we have become a layer on top of AWS, Azure, Infostellar, individual KSATs of the world. You basically are providing an antenna cloud for these mission owners to up and downlink from anywhere. Consequence of that is the Jeremy's question earlier. Now, truly, you can achieve low latency, right? So you can now achieve low latency. Absolutely.
This sounds very exciting and useful. It also sounds very complicated, right? On the aspect, because you're talking about multiple partners and service providers, and you're integrating them all and making a convenient platform. Sounds like it would be very challenging to simplify and make a clean, even just making a clean UI UX experience for
therein lies you hit nail on the head, Jeremy. So it's all about that user experience. I'm very big on that. So the full frictionless experience brought through that workflow absolutely abstracts and encapsulates all of those complexities, and essentially you'd only see, okay, these are the antenna partners that are available, and essentially you book the minutes. Especially when you are doing your operation, you can see these antenna partners or ground station partners on the platform. You can now book minutes or capacity on demand and pretty quickly before the satellite comes over. So it is really bringing down to near real time to get the antenna or the ground station contact and either uplink or downlink.
Yeah,
without having to have these long-term contracts.
Yeah, I get it. I mean, like, it's like how Steve Jobs says, I mean, simplifying things and also giving a very good user experience is actually the toughest part.
Correct. That's right.
Awesome. Thank you so much, Shankar. So I have one other question. This is more oriented, to future products and the future vision of the company. But right now, for some context, NASA is stimulating all of this development of the moon ecosystem with $50 billion plus, I think the last time I checked, combined on the Artemis program. And of course, China and other nations are also getting involved in this sort of new race to the moon. So my question is, if you have considered offering this service, not just around the Earth, but maybe cislunar or lunar based satellite as a service, or maybe in the future, if Elon Musk gets humans to Mars, maybe extending it to Mars. Like, how far out does the vision of Antares extend, in terms of physical space and applications?
Right, great question. And so far, in terms of just to execute the vision we've been talking about in the last hour, and to bring that to fruition, we are talking about at least 2 years, right? Because in order to get to the level of this kind of sophistication and simplicity, while abstracting away all the complexities and not really everyone having to worry about what's under the hood, that's a 2-year journey, right? So our version 1 of that will be released soon after our tech demonstrator in July. So that's the version 1 of the software, and then it'll go through multiple releases and versions over the next 2 years at least, to the point that we are now doing, real-time digital twinning instance. We are doing simulation in real time and so on and so forth. So it's a DTI journey, that or digital twinning instance journey, that we are working towards. And so to get to that point is 2 years, and thereafter, I'm sure, and this is the beauty of the open source, right? The community will inform us, because we don't know everything. We have a view of the world as to where we think the problem areas are, and that's what we are starting to solve today. But we may be very surprised 6 months down the road, the community says, no, that's all good, but these are other harder problems, right? So for example, one of the harder problems is software-defined radio, right? So while it's well and good to have a satellite, that is kind of how we are architecting it to be, it's modular, distributed, plug and play. So, we're running 3 computers. Some components like the core bus is running real-time operating system RTOS, and others are running Linux distribution. You can BYO your whatever distribution you want, or whatever RTOS you want. And there's an edge compute that has got its capability. So interestingly, we'll be flying one known edge compute and one unknown, one from a startup. So we're also qualifying a startup's edge compute capability. So while we're doing all this, the software-defined, the radio still remains the biggest bugbear in this whole thing. It's like we may need a Tariq. We need a Tariq here, right? For example, because what Tariq has done with in Rakuten Mobile in terms of how he has pushed through this virtual open RAN, that doesn't exist in whether if I want to do my S-band, X-band, KA, KU, LC, it's all tied to the radio. So we truly want to abstract the hardware away and provide a truly open SDR where you can communicate in any waveforms and frequencies. So that is by itself is another startup, if you think about it. But we want to solve some of it, not all of it, but some of it by providing an Antaris open API layer for SDR. So you can bring your own SDR, XX, SX, whatever bands spectrum you want to be working with, and integrate to this API from the Antares satellite platform, rather than to go do point-to-point integration, right? So we kind of providing encapsulate layer, but we are not necessarily solving that problem of, hey, BYO your radio, the hardware, and work with one piece of software, like what Rakuten Mobile was pushing towards. And then the same thing has to get repeated on the ground segment side. You need an SDR capability also on the ground segment side, not just on the spacecraft. So the likes of AWS, Azure are also starting to think about what does it mean to have a truly open software-defined modem-based processing on the ground segment side, so that it is not stovepipes. Right now, if you look at it, there are stovepipes, right, between spacecraft and the ground segment. We need to break that stovepipes and create that open layer both on the spacecraft and on the ground segment.
Okay, yeah, thank you so much. It was very interesting. So what would you say your key takeaways are from your experience at Planet, specifically at Planet Labs?
Good question. So I think the biggest value is Planet exposed me to the space, because that was my stepping stone into the second career, the space career, right? So think of this as my second career. So I had a technology career and I kind of moved into space career, and with Antaris, I'm trying to bring the two together. We are fusing the technology and the space in Antares, but essentially Planet gave me that second career opportunity to learn space, because had I not been in Planet, I would not have been able to then move along and learn more about the likes of how Spire is conducting its business, or the likes of Satlogic, which I had the pleasure of consulting for, right? So I think Planet was the stepping stone for me to get the exposure to other new space companies, absolutely. And having done that round, I could see where some of the challenges and opportunities were, and that's why the Antares was possible. Yeah, and obviously the other co-founders also, in their own regard, saw the like if you take Karthik, he was the CTO at Planet, so he also firsthand saw some of the opportunities and challenges before he walked in as a CTO of Planet to when he left. There was a transformation. So there were also those lessons that the likes of Tom and Karthik also learned in their time at Planet. So we brought all of that together in creating this proposition.
Okay, yeah, I mean, some few final questions from our side. So how do you think new space is going to evolve moving forward? And what would you like to say to those who like to work in new space, or probably who want to get into the entrepreneur bandwagon of new space?
Right. So the entrepreneur bandwagon of new space, I think that the most important thing is start with the problem. Otherwise you might be building something that nobody probably wants. I think it's an old adage. It's a great wisdom. So we spend a fair bit of time doing research, and a lot of that also, that research was not just going out and talking to who we consider to be prospective users of the Antares platform. So we spoke to integrators, we spoke to space agencies, we spoke to universities, we spoke to defense and intelligence. Think about it, defense and intelligence community also wants to have their own space capability, right? So that is the new emerging. As you can see, there's a space force. There's a space force in the US, there's space force in Australia. Most nations will have space force moving forward. So that is a huge opportunity. And again, Antares-like proposition with that open source element, while having a packaged commercial distribution, is very attractive, because you are not losing the sovereignty. If you are building something on Antares platform, that is your sovereign IP, right? So for defense intelligence, that's very important too. Rather than just, as I say to people, whether it's space agency or defense or others, the focus should be on not technology transfer, which is what has been happening. Like, as you know, people now go to work with JAXA, right? So they will collaborate with JAXA or collaborate with ESA, and there's a bit of a technology transfer. There's no technology ownership, right? Even if you, so you want to have technology ownership, and that is going to be possible with Antares because of that open source model, right? So, and because any IP you build on top of that, that's your IP, that's your ownership, right? It doesn't mean you have to. We will have the open source license such that you don't have to contribute back if you don't want to. Anyway, so that said, I think you got to start with the problem. And once, if you are looking at entering new space, or basically, and the question then you would have to ask is, why are you looking to enter a new space? Because it's cool and sexy, or because you think there's a problem, right? So if you identify a problem, absolutely, you should enter to solve that problem, right? So I would say part of our inspiration also came from Elon, because in a way, subconsciously, we didn't think it that way. But when you start to talk about it, it made sense, because Elon looked at the way launch business was being done. It is highly inefficient. He said, like, I don't burn a plane. After I go from point A to point B, I don't burn the plane. I get the plane to correct, right? That's a very, very, very wise thing to say. I don't blame the plane. So why is that in launch business? Why we burning the rocket, right? So that's the birth of the reusable rocket. Similarly, we looked at, hey, hold on a second. Why is that everybody reinventing the satellite wheel every time they want to build a mission? Right. So it is all about removing that reinvention, and which then means we have to then have reference designs. We want to have reference design that people can just, it's like AWS, going on AWS and able to pick a few things and start developing your application, right? Same thing. You want to have reference designs. You want to be able to give as much as 50, 60, 70% through your low code platform so that people then work on the remaining 20, 30, 40, 30% to finish their, mission assembly. So it's really, seeing that opportunity to remove that friction, make it easy. That's how we identified a problem and we came up with this as a solution, right? To essentially remove the reinvention problem and therefore reduce or preserve the capital or reduce the resource wastage, whether it's in time, money, and resources.
And maintain the cash flow too.
Yeah, you want to, absolutely.
Great. Well, Shankar, thank you so much for joining us today on the Entrepreneurial Space podcast. We wish you the best. We wish you the best and look forward to you achieving your vision of Antares making space accessible to everyone through satellite as a service.
Thank you, Shankar.
Thank you so much. Thanks, Jeremy. Thanks, Balaji. Thanks for having me.
Thanks for listening to the Entrepreneurial Space podcast. I'm your host, Jeremy Anderson, here with co-host Balaji Santhanam. If you like this interview, please subscribe, tell a friend, and give us a review.